Greetings. I'm Dave, going by Geezer Geek here on YouTube. Thank you for taking an interest in my video. If you like what you see today, please go ahead and hit that like button, and if you'd like to do so, go ahead and subscribe also. I'm planning to produce about a video a week. That should now be possible, I hope. This time I'm exploring whether there are productivity reasons to switch from a stock CPU cooler to an aftermarket cooling solution. And the too long didn't read or didn't listen version of it is, I went ahead and went with the Ninja 5, primarily for sound and thermals, even though I could not prove an improvement on throughput. Now, as I see it, there are just 4 possible reasons for swapping out a CPU cooler. One is the stock cooler is inadequate to the task, so you get thermal throttling as you try to work with your computer. Another might be that the stock cooler is noisier than you like, and some aftermarket cooling solution is quieter. A third might be simple aesthetics. You hate the looks of the one or love the looks of a different one. Beauty is in the eye of the beholder. Now, a fourth might be that you've heard about liquid cooling and you just want to give it a try. Now, liquid cooling has its own set of concerns that should be considered before going down that road. We're not going there. And for the present, I also am not really concerned about aesthetics. Now, while some may think, perhaps most, may think that AMD's stock solution is ugly as sin, aesthetics are a very subjective matter. And as this is a black box case that I'm working with, where the cooler's never seen, aesthetics really is the least of my concerns for this video. What does concern me is noise, and even more importantly, not having my throughput choked because of thermals. Having a noisy office is not good for productivity either, so both of these are productivity concerns for me. So these issues are the issues being addressed in this video. And in it, I am working with an 8-year-old build that used an FX 4100 CPU, not overclocked. And you may have seen other videos that use artificial workloads to do benchmarks. I'm not interested in theoretical results, but practical real-world results. So here are my questions. Does an aftermarket solution make any difference in the noise in my office? Does an aftermarket solution make a difference in the thermals, a significant difference in the thermals for my CPU? On the thermal question, there are actually a couple of ways of considering it. One is, if the stock solution keeps the CPU in a safe operating range during your workload, is anything else significant? And the other is, in terms of absolute cooling. Is it important for some reason to keep the CPU at a lower temperature than the stock cooler can manage, even if the stock cooler keeps it safe? So, there's several questions. Where do we start? Let's go with the noise question first. The CPU cooling solutions I've checked for my situation in preparing this video are the AMD stock cooler and a Cooler Master MA610P and a Ninja 5 by Scythe. Now, how to measure noise. You have your subjective experience of it. That's one way of approaching it. But there are other ways of trying to get more objective results. And while the pulse audio volume meter has no scale displayed for decibels or relative volume, it does give a visual measurement. And if you do a recording of it, and then stop the recording and use a ruler to measure the peaks, the valleys, and the average, or what appears to be the average, then you have something measurable, something objective. Doing this, the Masterair MA610P is certainly the loudest of these thermal solutions. This was consistent with my subjective experience of them. And while it was close, it did seem to me that the Scythe Ninja 5 was quieter than the AMD stock cooler. Thermals are a trickier matter. You should be aware that there are three components to your thermal solution. One is how well heat moves out of the case. Since my setup was the same for all three of these, this side of the test was constant, so not a factor in the testing. Another component is the thermal interface material, or TIM. It's sometimes called thermal paste or thermal grease or thermal compound. And there are some pretty fancy solutions out there. But for most end users, those fancy solutions may not make a whole lot of sense. For instance, there is that new carbon sheet interface that some of the big names in extreme cooling have been pushing, and one of its advantages is consistency in application, and another is in reusability. I do not anticipate changing out this CPU on this platform, so for me, reusability is not really a consideration. Whatever I get for this is single use, and I would need something new on the next machine because I do not anticipate swapping the CPU on this. And the size of that carbon sheet is specific to the CPU that you're working with. Now, liquid metal is another exotic solution, and you might gain a bit more efficiency with it, but unless you're an extremophile doing overclocking, that probably is not going to matter for you. For the end user who's not an overclocker, a thermal solution like Cooler Master's Master Gel Pro is probably a very good choice. Although you can get quite satisfactory results with the solutions that are provided by the makers. In this case, this is Scythe. Some of them are already applied to the heatsink itself. So it just depends on which one you're working with. AMD's solution does keep the CPU within its operating envelope. It's a finned chunk of metal, and it has a CPU cooling fan applied to push air in. The metal wicks heat away from the CPU, and then the fan disperses that heat into your case. And it's a proven technology, a simple technology. It works. It's been around since the days of power transistors back in the 60s, at least. It works. So long as you have airflow moving through your case, then the heat from your CPU is being taken out and moved into the room. Now, this is the first aspect of your cooling solution that I mentioned. You need airflow through your case. Now, the solutions by Cooler Master and Scythe use a technology called heat pipes. Inside the pipes is a material that changes from liquid to vapor as it heats, and then it condenses again as it cools. This is called a phase change. The fin arrangements of these coolers might remind you of an air conditioner, and they serve a similar function, moving the heat away from the heat pipes, allowing the condensation or phase change to take place. This is something like your process from an air conditioner, a heat pump, or a refrigeration system in a variety of locations. And one would expect this technology to keep the CPU cooler, and it does. The question is whether that delta or difference is significant. Now, if you're measuring that in terms of degrees cooler, then I would say, yeah, it's significant, perhaps very significant. But if your measure of significance is how well the computer is performing for you, that might be a different matter. Here's what I mean. You give the computer a task to do that runs the CPU at full load. Unless you're overclocking, your stock cooler should keep that CPU's thermals in a range that do not trigger thermal throttling. My test was a render project that took over an hour to complete, and with my setup, the CPU was about 90% the entire time. To share with you my testing process, what I've done is taken a screen grab from one of the tests, and I'll explain each of the components on this screen grab. This is what it looks like. So each of the components, starting in the upper left-hand corner, that is the test project. It's what's maxing my CPU. It's rendering a project, and that render process takes over an hour. Same project for each of the CPUs. That is important, as will be explained in a minute. In the lower left, you see pulse audio volume meter. You'll notice there is no scale on that, not decibels and not relative volume. But what you can do is stop the playback of the recording at the various locations when you have a peak, when you have a valley, when you have it what's appearing to be a midpoint. And you can take your ruler and measure those lines and see what the relative volume is. Then you can compare those objective measures between the various tests. Lower left, pulse audio volume meter. Lower right is P sensor, and the particular things that I'm tracking there are the CPU temperature, which at this point is ranging between 108 and 109 Fahrenheit, and CPU usage, which is that dark line at the top, and that is running in the neighborhood of 90 to 95%. Now that is the average of all 4 threads. I also wanted to use system monitor, which is the next piece in the upper right, and I just needed the CPU usage, and it's showing me that all 4 threads are in that same usage range. So the last piece that's getting an objective number for is the time it takes to complete the render using each of these coolers. So when that box in the middle disappears, it's done rendering. And then I stop the recording at that point. I play the recording back, and I note the timestamp when the rendering starts, and I note the timestamp when the rendering is completed, and now I know how long it took to do that project on that cooler, and I can compare those between the coolers. I have an objective measure for throughput now. I could not prove thermal throttling. Now, I didn't run the test multiple times, so I don't have any averaging to do. But here are the numbers. With the stock cooler, the time to complete was 1 hour and 26 minutes. With the Ninja 5, it was within a minute of that. More tests would be needed to say whether there was a real difference or a significant difference. So what's my conclusion? An aftermarket cooler will keep your CPU cooler and may, in some circumstances, prevent thermal throttling when your stock cooler is inadequate to the task. In some circumstances. In any case, there is a theoretical improvement to the expected lifetime of any semiconductor if you keep it cooler. Now, if you look at the reviews in terms of actual cooling, the Masterair MA610P by Cooler Master isn't really impressive. Second, some CPU coolers are quieter than your stock cooler. Others are not. Pay attention to the reviews. Once again, the Cooler Master MA610P is not the most impressive. And in my experience, it is easily the most noisy of these 3 thermal solutions. I did settle with the Scythe Ninja 5. Now, other considerations if you're considering changing your CPU cooler. 1. Pay attention to the space requirements. The specs provided on the box are accurate. Right there. They'll tell you how much space you need in order to work. Cooler Master has the same specs on its box, the same kind of specs on its box. One place where you can run into a problem is if you don't have enough height or the width of your computer case. If that cooler won't fit in the available space, you're going to leave the side of the case off? What are you going to do? In my case, the Cooler Master solution was just 1/8 of an inch too tall. At the other end of the cooler, you have another space consideration. Do you have tall RAM modules? If so, you'll need to look closely at the shape of this CPU cooler and make sure that it will go over your RAM modules, not give you problems. Another place where dimensions can show up as a possible issue is at the back of the case and at the top of the case. Is there room for your case fans if you have them? In my situation, there was not room for my case fan at the back of the case with this cooler and both of its fans installed. What I did is I removed my case fan and I used one of the Scythe fans as my new case fan in that location, and it's blowing straight into the cooler and it's doing its job. At the top of the case, you might be marginal on room also. In either of these locations, if I had had a 15 millimeter fan, 15 millimeter thick fan, instead of the usual 25 millimeter, it might have worked. But not having one of those on hand, I have no fan in either of those locations, except I put the Scythe in the place of the back fan. Other considerations, if you are after the RGB effects such as the Cooler Master's solution provides, now you're into aesthetics. Some will like it, others call it unicorn puke. But is it even seen? In my case, it's a black box case. Nobody ever sees it. I'm the only one who knows it's there. So the bottom line, the Masterair MA610P sells for around $90 US. The Ninja 5 sells for around $60 US, and in my case, the best advantage of the Ninja 5 is the noise. Is it worth the $60? For me, yes. It gives a more pleasant work environment. And it does keep the CPU cooler. And it's not expensive. And it's a cooler that I can later move to another platform if I choose. And there may yet be some performance advantages that I wasn't able to detect in this initial testing. This is good enough for me. Your mileage may vary, but thanks for watching, and I hope to have another video for you again soon.